Dear ladies and gentlemen, I am Masood Saeed, a psychologist in mental health and well-being. Welcome to my YouTube channel, Words of Inspiration. This video will be discussing about brain parts and their functions explained. Today, we delve into the fascinating perspectives offered by renowned Islamic scholars and accomplished Muslim doctors on brain functions. Throughout history, the Islamic world has contributed significantly to the fields of science and medicine. First, let's hear from Al-Razi, a Persian polymath known for his works in medicine. He described the brain as the seat of intellect and emotions, emphasizing its critical role in human consciousness. He believed that understanding the brain was key to understanding human behavior and mental health. Next, we turn to Ibn Sina, also known as Avicenna. His monumental work, The Canon of Medicine, detailed the brain's anatomy and functions with remarkable accuracy. Avicenna's insights laid the groundwork for modern neuroscience, highlighting the brain's role in controlling the body's movements and sensory experiences. In contemporary times, Dr. Aafia Siddiqui, a neuroscientist, has conducted extensive research on brain functions, especially focusing on memory and learning processes. Her work underscores the complexity of neural networks and their impact on cognitive abilities. These scholars and doctors have provided invaluable insights into the brain's workings, demonstrating a rich heritage of knowledge that continues to influence modern science. Join us as we explore the intricate details of the brain structure and functions in the next segment. This is going to blow your mind. Let's explore the powerhouse that runs our body, the brain. First up, the cerebrum. Section 1. Cerebrum structure, largest part of the brain, divided into left and right hemispheres. Functions: frontal lobe, responsible for decision-making, problem-solving, planning, and voluntary movement. Parietal lobe processes sensory information like touch, temperature, and pain. Temporal lobe handles memory, emotions, language comprehension, and auditory processing. Occipital lobe, specialized for visual processing. Evidence: studies using fMRI, functional magnetic resonance imaging, demonstrate how different lobes activate during specific cognitive and sensory tasks. Cohen et al. 2000, Journal of Neuroscience. It is the largest part, handling thinking, memory, and voluntary movements. Dr. John Medina, in his book Brain Rules, 2008, states, "The human brain is the most complex organ in the known universe." Think of it as your brain's CEO. The cerebrum is divided into two hemispheres, each responsible for different functions. The left hemisphere is often associated with logical thinking, language, and analytical tasks, while the right hemisphere is linked to creativity, intuition, and spatial abilities. These hemispheres communicate through a bundle of nerve fibers called the corpus callosum. Section 6. Corpus callosum structure, a bundle of nerve fibers connecting the left and right hemispheres. Functions: facilitates communication between the two hemispheres, integration of sensory and cognitive information. Evidence: studies on split brain patients show how severing the corpus callosum impacts coordination and perception. Gazzaniga, 2000, Nature Reviews Neuroscience. The corpus callosum is a thick bundle of nerve fibers that connects the left and right hemispheres of the brain, enabling communication and coordination between them. It is the largest white matter structure in the brain and plays a crucial role in integrating sensory, motor, and cognitive functions. Next, the cerebellum. Section 2. Cerebellum structure, located beneath the cerebrum at the back of the brain. Functions: coordination of voluntary movements, balance and posture, fine motor skills. Evidence: damage to the cerebellum causes motor impairments, as shown in lesion studies. Manto et al., 2012, Frontiers in Neurology. This little guy is all about coordination and balance. Research from the University of California 2014 suggests that the cerebellum contains over half of the brain's neurons. The cerebellum is also involved in motor learning, helping you refine movements and develop skills through practice. If the cerebrum is the CEO, the cerebellum is the master conductor of an orchestra. It ensures that all parts of your body move in harmony, maintaining smooth and precise movements. Then we have the brainstem. Section 3, brainstem structure, connects the brain to the spinal cord, consisting of the midbrain, pons, and medulla oblongata. Functions: regulates autonomic functions such as breathing, heart rate, and blood pressure. Controls reflex actions like swallowing and coughing. Evidence: autonomic dysfunction following brainstem damage has been documented in clinical cases. Benarok, 1993, Mayo Clinic Proceedings. It controls basic life functions like breathing and heartbeat. The National Institute of Neurological Disorders and Stroke, NINDES, notes that the brainstem is crucial for survival. The brainstem is composed of three main parts: the midbrain, pons, and medulla oblongata. Each part plays a vital role in regulating essential functions such as sleep, arousal, and reflexes. Picture it as the autopilot system. It keeps your body running smoothly without conscious effort, allowing you to focus on more complex tasks. Don't forget the limbic system. Section 4. Limbic system structure includes the hippocampus, amygdala, thalamus, and hypothalamus. Functions: hippocampus, key for memory formation and spatial navigation. Amygdala, processes emotions, particularly fear and pleasure, kasi. Thalamus, acts as a relay station for sensory and motor signals. Hypothalamus, regulates homeostasis, including hunger, thirst, and body temperature. Evidence: patient HM's case, where removal of the hippocampus resulted in severe anterograde amnesia, highlights its role in memory. Scoville and Milner, 1957, Journal of Neurology, Neurosurgery, and Psychiatry. This is your emotion and memory center, the brain's emotional engine, driving feelings and memories. Dr. Paul MacLean described it as the emotional brain in his triune brain theory, 1990. The limbic system includes structures such as the hippocampus, amygdala, and hypothalamus, each contributing to different aspects of emotion and memory processing. Section 5. Basal ganglia structure, group of nuclei, including the chordate nucleus, putamen, and globus pallidus. Functions: motor control and learning, habit formation and reward processing. Evidence: disorders like Parkinson's disease and Huntington's disease are linked to basal ganglia dysfunction. DeLong and Wichmann, 2007, movement disorders. The basal ganglia is a group of interconnected structures located deep in the brain that plays a crucial role in various functions, including motor control, cognitive processes, emotions, and learning. Section 7. Hypothalamus structure, small P-shaped structure below the thalamus. Functions: regulates the endocrine system via the pituitary gland, controls circadian rhythms and body temperature. Evidence: research shows hypothalamic involvement in stress responses via the HPA axis. Ulrich, Lai, and Hermann, 2009, Endocrine Reviews. The hypothalamus is a small but crucial part of the brain located below the thalamus and above the brainstem. It serves as a control center for many autonomic and endocrine functions essential for maintaining the body's internal balance, known as homeostasis. Section 8. Ventricles and cerebrospinal fluid structure, a system of interconnected cavities within the brain. Functions: protects the brain from injury, facilitates nutrient and waste exchange. Evidence: studies show increased ventricular size in conditions like hydrocephalus. Bradley et al. 1991 Radiology. The ventricles and cerebrospinal fluid (CSF) are essential components of the central nervous system (CNS) that work together to protect and maintain the brain and spinal cord. The ventricles are interconnected cavities within the brain filled with cerebrospinal fluid. It regulates body temperature, hunger, and thirst. According to Harvard Medical School, 2015, the hypothalamus plays a key role in maintaining homeostasis. The hypothalamus also controls the release of hormones from the pituitary gland, influencing various bodily functions such as growth, metabolism, and stress response. It's like your brain's internal thermostat and pantry manager. It ensures that your body remains in a state of balance, adjusting physiological processes as needed. Together, these parts keep you thinking, moving, feeling, and surviving. Amazing, right? The brain's intricate network of neurons and synapses allows for incredible feats of cognition, emotion, and physical coordination. It's a marvel of biological engineering, constantly adapting and rewiring itself in response to new experiences and information. So the next time you ponder a complex problem, enjoy a beautiful piece of music, or simply take a breath, remember the incredible organ making it all possible, your brain. Do not forget to tap on the like, share, and subscribe buttons. Please leave a comment